In this video, we're going to be solving algebraic equations by isolating the variable and finding what it's worth. In this case, I have a fairly simple one to start out. This is b plus 3 equals 12. Now, a lot of people can see just by looking what this is going to equal, because basically you can look at it and say that it's something plus 3 that'll get me to 12. So you can kind of identify it just with your own plain number sense. But as these get more complex, it's helpful to have some rules and some strategies that you can use to help you get there. A lot of people would say to you that your next step would be that you would write b equals 12 take away 3. And when you're asked why, you're often told, well, this is a positive 3, so if I just bring it to the opposite side of the equal sign, it's going to become a negative 3. But there is a reason for that, and it's kind of important to know, so we should take a look at what that is. I want to isolate b by itself. So what I'm going to do is I'm going to look for a way to get rid of this plus 3. I want to get b so it's all alone. I'm going to get rid of this plus 3. How can I get rid of positive 3? I can subtract 3. That will get me to 0, and it won't be there anymore. So I can literally subtract 3 from this side. Now, that'll leave me with b over here, which is good, just b. But I'm a little tripped up by this equal sign. The equal sign means that whatever I do to this side, I must absolutely do the same to this side. It's a 100% guarantee. That's what that equal sign means. That means then that if I subtracted 3 from this side, I also must subtract 3 from this side as well. So I'm going to subtract 3. 12 subtract 3 is 9. And what I'm left with is b equals 9. What I like about these questions when students are working on them is they can easily go back and check by substituting. So they can rewrite the equation as this. b equals 9, so 9 plus 3 equals 12. And they can check to see if it's correct. If it is, then they know they've done it correctly. Let's go to a slightly more challenging example. And we'll use some multiplication. This could also be written as 7 multiplied by b equals 42. Oops, 42. But often we get rid of the multiplication sign because it's understood that a 7 beside a b means that those two are multiplying together. So in this case, again, I want to isolate b, but adding and subtracting is not going to help me here. So I need to figure out how I can get rid of this 7. If I've got a 7 and I want to get rid of it and I'm multiplying, what I can do is I can divide that number by itself, which will not get me 0, but it'll get me 1. And we know that 1 times any number equals that number. So for example, I can change this to 7 divided by 7, and that will give me 1b. And we know that 1 times b is the same as just b. 1 times any number gives me that same number. 1 times 2 is 2, 1 times 100 is 100. Now, as we said before, if I divide this side by 7, I must also divide this side by 7. 42 divided by 7, hopefully I remember in my multiplication table, gives me 6. So 1b equals 6, or b equals 6. We can check again. I can say 7 times 6 instead of b equals 42. So that one is correct as well. Again, I really like that we can look back. Our final step is to look back. We can look back and check and see that.